Hello student, in previous lecture we have seen absolute value function and some properties and example related to absolute value function. Now in today's lecture we are going to start the last topic of this chapter, completeness properties of R. Now first definition, upper bound. Upper bound. Let S be any non-empty set subset of real number set R, then and U belongs to R is called upper bound for set S if if x is less than or equal to U for every x belongs to S. Means what? All U is upper bound means what? Or all the elements of set S is less than or equal to U, then U is called upper bound, and this set S is said to be bounded above, and then set S is bounded above. So when we say a given set is bounded above, if it has a upper bound. For example, if we consider S is equal to 1, 2, 3, 4. So if you observe that this set is bounded above. Why? Because all these numbers are less than or equal to 4, 5. They are all upper bounds. What are the upper bounds of this? So they are all upper bound. So this set is what? Bounded above. Now next, bounded below. Next definition, bounded below. Again, if S is given any non-empty set, subset of real number R, and L belongs to R, real number, L belongs to R is called lower bound of set S if L is less than or equal to X for every X belongs to S. Okay, and if there exists a lower bound, then we can say that set S is bounded below. Now then what is meant by bounded? If given set is bounded below and bounded above, then it is called bounded set. Now look at this example. Suppose S is equal to 1, 2, 3, 4 and 5. So all of you know that this set is bounded above. What is upper bound? 5. And what is lower bound? 1. So all these elements are lie between 1 and 5. So this set is bounded above and bounded below, and therefore this set S is not bounded. It is not bounded. How many upper bound for this set? या सेटला किती upper bound येतात? 5 आहे, 5.1 आहे, 5.2 आहे, 6, 7, 8. They are all upper bound. What is the lower bound? Lower bound means what? की असा नंबर आपल्याला फाइंड करायचे की ज्यापेक्षा हे सगळे नंबर ग्रेटर दॅन आहेत. मग असा 0 आहे, -1, -2, all the numbers lie between 0 and -1, that is 0.1, 0.2. All these numbers are lower bound for this set, and therefore this set is bounded. Take one more example. S is equal to 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. Suppose if you take this infinite set, you want to check whether this set S is bounded or not. So if you observe, all these numbers or this set has an upper bound, that is all these numbers are less than or equal to 1, and all these numbers are greater than or equal to 0. So if you observe, 0, -1, they are all lower bound. 1, 2, 3, 4, all upper bound. So this set has upper bound and lower bound. Therefore, this set is what? Bounded set. So hope you understand what is meant by bounded set. Now next definition is supremum. Supremum. Supremum, or it is also denoted by SUP, or it is also called least upper bound. So it has two names, either you can call supremum or least upper bound. Least upper bound. Okay, so given let S be any non-empty set of real number, then U is called supremum of S if first U is upper bound of S set S, and number 2, if there exists V is also upper bound for S, then U is less than or equal to V. Means what? This is the least upper bound. This is what? Least upper bound. So it is, and it is called supremum of set. For example, okay, I am going to take also infimum also, and then I am going to take an example. Infimum, or it is denoted by I and F. So what is the supremum of S here? It is denoted by SUP of set S is equal to U, or LUB of set S is equal to U. So now infimum, again L is called infimum if first condition here is lower bound, it must be a lower bound of the given set, and if there exists another lower bound, suppose here is also lower bound for set S, then M is less than or equal to N. Means what? L is the greatest lower bound. If you collect all the lower bound, then the greatest of the lower bound is called the infimum. Least of the upper bound is called supremum, and it is denoted by I and F of the given set S is equal to L, or GLB of S is equal to L. Now you can I am going to clear this concept by using an example. So suppose we take the previous example. Suppose that S is equal to 1, 1 by 2, 1 by 3, 1 by 4, and so on. And you want to determine what is the supremum and infimum of this set. All of you know that what is the upper bound? What are the upper bound of this set? Upper bounds are 1. All the numbers which are greater than or equal to 1, they are all upper bound for this set, because all these numbers are greater than or less than or equal to 1, and higher number greater than or equal to 1, that is 1.1, 1.2, 2, 3, 400, they are all upper bound. But what is the least upper bound? Or you can observe that the 1 is the least upper bound. All these numbers are less than or equal to 1. There does not exist another number which is less than 1 and which is also upper bound for this set, and therefore 1 is what? 1 is the least upper bound. So what is the supremum? Supremum of set S is what? 1. Now you can observe that there are infinitely many upper bound, but supremum is unique. Supremum is what? Unique. Then what is the lower bound of this set? You can observe that this sequence is stopped, that is all these numbers are greater than or equal to 0. 0.1, minus 1, 1. But 0 is the last, that is 0 is what? Infimum, greatest lower bound. If you collect all the lower bound, then the greatest of the lower bound is what? 0. And therefore what is infimum of set S? Infimum of S is what? 0. Now next, you could take one more example. S is equal to n, where n belongs to n, set of natural numbers. Then you can observe that what is this set? This set contains numbers 1, 2, 3 up to infinity. So this set has no supremum. Supremum does not exist. Does not exist because this set has no upper bound. Does not exist. And what is the infimum? Infimum, all these numbers are greater than or equal to 1. So what is infimum? Infimum is 1. Next example, suppose S is equal to n, where n belongs to 1 by n belongs to z, set of integers. Set of integers. So if you observe, what is this set? S is equal to minus 1 by 3, minus 1 by 2, minus 1, 0, 1 by 2, 1 by 3, 1 by 4 and so on. So this is the set. So if you observe 1 also, 1 by 2, 1 by 3, 1 by 4 and so on. So if you observe, if you draw the geometrical representation, you can easily identify that all these numbers are less than or equal to what? 1. All these numbers are less than or equal to 1. So what is supremum here? Supremum is equal to 1. And what is infimum? All these numbers are greater than or equal to what? Minus 1. Greater than or equal to minus 1. So what is infimum here? Infimum is what? Minus 1. Take one more example. S is equal to minus 1 raised to n divided by n. N belongs to set of natural numbers. So find the supremum and infimum of this set. If you guess this set, okay, in your mind, then you can easily identify. First, what is the first step to find the supremum and infimum? You must identify what will be the upper bound for this set. What is meant by upper bound? You want to determine a number such that all these numbers are less than or equal to that number, and it is called upper bound. Or if you want to determine a number such that all these numbers are greater than or equal to that number, so it is called a lower bound. Once you identify upper bound and lower bound, then you can easily guess that what will be the supremum and infimum of this set. So first of all, if you write some elements of this set, n, if you take n equal to 1, then it is equal to minus 1. If you take n equal to 2, then it is 1 by 2, minus 1 by 3, 1 by 4, minus 1 by minus 1 by 3, then minus 1 by 5, 1 by 6 and so on. So if you observe, there are combination of some positive numbers and negative numbers. So what will be the upper bound of this set? If you observe, all these numbers are less than or equal to 1 by 2. All these numbers are less than or equal to 1 by 2, because what are the positive number? 1 by 2, 1 by 4, 1 by 6, and these are the decreasing sequence. Okay, that is 1 by 4 is less than 1 by 2, 1 by 6 is less than or equal to 1 by 4. Also, this minus 1 is also less than 1 by 2, minus 1 by 3 is also less than 1 by 2, minus 1 by 4 is also less than 1 by 2. So all these numbers are less than or equal to 1 by 2. So what is the supremum? Supremum of this set is 1 by 2. What is infimum? Infimum is equal to. Now you want to determine the lower bound of this set. So if you observe, all these numbers are greater than or equal to minus 1. All these numbers are greater than or equal to minus 1. So what is infimum? Infimum is what? Minus 1. So and do remember one thing, it is not necessary that upper and lower bound must belong to that set. It may be outside of the set. So now next, there is one density theorem, that is between any two real number there exists a rational number, and density theorem. First, between any two rational, there exists irrational number. There exists irrational number, and number two, between any two irrationals, there exists a rational number. What this density theorem says, all of we know that what is a rational and irrational number. I have already explained what is the difference between the rational number and irrational number. If you don't know, go to the first lecture of algebra. There I have uploaded one video on set theory. In that lecture we have discussed all the standard set of set, that is natural numbers, integers, rational, irrational. In that set you can easily identify that the difference between rational and irrational. And all of we know that the union of rational and irrational form the set of real number. So rational number is of the form p by q, or it is a terminating or a repeating decimal fraction. Or what is the irrational number? It is non-terminating, non-repeating decimal fraction. It is called an irrational number. So between any two irrational number there exists a rational number, and between any two rational number there exists a rational number. So now in exam there is a question like this: find a rational number between find a rational number between under root 3 and under root 5. So, want to determine, all of you know that these two are the irrational number, because the square root of any prime number is an irrational number. So, all of these two are irrational number, and we want to determine a rational number between root 3 and root 5. All of you know that there are infinitely many rational numbers between root 3 and root 5, but you want to determine single rational number between root 3 and root 5. So how to determine? Consider n square 3 less than n square less than n square 5. So you have to consider this statement. That is, you have to remove this square root and multiply by m square. Take n square between and take m square multiply. Take any number. Suppose if you take m is equal to, take any value of m. You can take m is equal to 1, m equal to 2, m equal to 3, m equal to 5, m equal to 6. If you take m equal to 2, then what happens here? 2 square is 4, 4 times 3 is what? 12, less than n square, less than 2 square is 4 times 5 is what? 20. So you want to determine a perfect square you want to determine a number whose perfect square you know. So all of you know that the between 12 and 20 there exists a number 16 whose square root is what? 4. So we know that the 12 is less than or equal to 16, less than or equal to 20. Now take square root on both sides. So if you take the square root on both sides, it is less than or equal to 4, less than or equal to 20. So all of you know that what is the 12? 12 is what? 2 under root 3 less than or equal to 4, less than or equal to what? Under root 2 under root of 5. So if you divide by 2 on both sides, you get under root of 3 less than or equal to 4 by 2 less than or equal to under root of 5. So this is the rational number between under root 3 and under root of 5. If you change your m is equal to 3, if you change m is equal to 3, then what happens? 3 square is what? 9 times 3 is what? 27. 27 less than n square less than 9 times 5 is what? 45. So the perfect square number between 27 and 45 is what? 36. 36 is less than 45. So, when you take the square root on both sides, 3 square root 3 less than or equal to 6 less than or equal to what? Less than or equal to 3 under root of 5. So here, if you divide by 3, again you will get one rational number between 3 and 5, that is 6 by 3. So this way you can easily identify a rational number between any two irrational number. So again there is a one question like this: find an irrational number between any two rational number. So for example, you want to determine a irrational number. Determine irrational number between 3 and 4. Find the irrational number between 3 and 4. So how to determine 3 and 4? Just consider the statement 3 square less than 3 less than 4 square. Now find a prime number which lie between 3 square, that is 9, less than or equal to p less than or equal to 16. All of you know that 11 is there, then 13 is there. So you can take any rational, any prime number which lie between 9 and 16. Suppose you take here 11, then you take the square root on both sides, that is 3 less than or equal to 11 less than or equal to 4. So 11 is the irrational number between 3 and 4. If you take the here 13, then square root of 13 is also lie between 3 and 4, which is also irrational number between any two rational number. So hope you understand this topic.